Welcome to the third part of our limits at infinity. The precise definition of this is let f be a function defined on some open interval a to infinity. Then the limit as x approaches infinity of f of x is equal to L means that for every epsilon greater than 0, there is a corresponding number capital N such that if x is greater than capital N, then the absolute value of f of x minus L is less than epsilon. So the values of f of x can be made arbitrarily close to L within a distance of epsilon, as we could see in this graph here with this yellow box, that distance of epsilon on either side of L. By requiring x to be sufficiently large, larger than capital N, well, capital N depends on epsilon, which you could see we could have capital N being here. That means x would be someplace in this yellow box region in this graph. And the same thing can happen with the negative infinity. So let f be a function defined on some open interval, negative infinity to a, then the limit as x approaches negative infinity of f of x is equal to L, means that for every epsilon greater than 0, there is a corresponding number capital N such that if x is less than capital N, then the absolute value of f of x minus L is less than epsilon. So just quick note, that means unlike this particular graph, this then capital N would be like someplace down here. And then x would be in this region here. And we would have that epsilon neighborhood based on this as well. Here and here. But here's another example. Based on this graph here to the right, we want to find the limit as x approaches infinity of f of x. So as we move towards the right here and x increases, we can see this graph approaching and approaching and approaching this value of -2. But the limit as x approaches negative infinity, we could see as we increase x negatively, the function gradually approaches the value of +2. If we let the limit as x approaches +1 of f of x, we could see if no matter if we're talking about the right or the left-hand limits, both of them approach very large numbers as x approaches 1. So this is positive infinity. Likewise for 3, talk about the right or the left, the values of x increase negatively, so this would be negative infinity. So based upon what we see here, the asymptotes that we have for y are both positive and -2. And for x, this will be 1 and x is equal to 3. So a total of 4 asymptotes based on this graph. To find the limit as x approaches infinity of the square root of 9x squared plus x minus 3x. We're going to multiply by the conjugate. So square root of 9x squared plus x plus 3x on both the numerator and the denominator. So square root of 9x squared plus x plus 3x. So doing this, continue it down here, this being the limit as x approaches infinity of multiplying this expression with the numerator allows us to cancel most of that out. This is 9x squared plus x minus 3x. Minus 3x squared, so minus 9x squared. Divided by the square root of 9x squared plus x plus 3x. So we could cancel out in the numerator just to get the limit as x approaches infinity of just x divided by the square root of 9x squared plus x plus 3x. And now we could divide the numerator and the denominator now by a value of x. So, and the reason why this is x is because of this square root in here. So these are no longer the values that they have inside of there due to that denominator, number one. And then number two, because of underneath that square root, the highest power of x now in that denominator is x. So we can do this as the limit as x approaches infinity of, this would then be 1, divided by, we would have the square root of 9 plus 1 over x. That's from when we're dividing this, we were able to do like we did on the previous example, square root of 9x squared plus x divided by x. Since we are talking about positive values, this is the same thing as 9x squared plus x divided by x squared, which simplifies to make this plus 3. And now applying that limit, we get 1 divided by the square root of 9 plus 3, so 1/6 would be the limit in this particular problem. And then lastly, I have one more. Finding the horizontal and vertical asymptotes of the curve y is equal to x squared plus 1 divided by 9x squared minus 80x minus 9. So, to begin with, we could apply the limit as x approaches infinity of x squared plus 1 divided by 9x squared minus 80x minus 9. Dividing everything by an x squared, the highest power of x in the denominator, we would get the limit as x approaches infinity of 1 plus 1 over x squared divided by 9 minus 80 over x minus 9 over x squared. And this would become just 1/9. Likewise, we could also show the same thing, that when we take the limit as x approaches negative infinity of the same function, x squared plus 1 divided by 9x squared minus 80x minus 9. This would also give us a value of 1/9. So we have that one asymptote already. We have two other ones. 9x squared minus 80x minus 9. That factors to be 9x plus 1 times x minus 9. So the other two asymptotes that we have, so this was y is equal to 1/9. These two are x is equal to negative 1/9 and x is equal to 9 as our three asymptotes for this particular problem. Let me know if you have any questions or concerns. Thank you.